Imagine a future where the internet isn't hosted by a few powerful companies such as Amazon, Microsoft and Google, but by every computer around the globe, making Web3 more secure and decentralized than ever. This is where the Internet Computer Protocol comes into play. Internet Computer Protocol is a blockchain specializing in Web3 that aims to create a decentralized version of the Internet where independent data centers provide an alternative to corporate cloud services that make up today's current version of the Internet known as Web 2. In short, the Internet Computer Protocol predicts that most of the world's software will eventually be replaced by smart contracts. As such, and to help achieve this aim, Internet Computer Protocol is designed to make smart contracts as powerful as traditional software. But how exactly does it do this? And what are the benefits to the end users? Watch until the end as I am about to explain what the Internet Computer Protocol is, how the Internet Computer Protocol works, and what the ICP tokenomics are. If you like the content, make sure to subscribe to the channel and let me know in the comments below what projects you would like to see next. The Internet Computer Protocol was created and released by Dfinity, whose founder and CEO is Dominic. Internet Computer Protocol itself went live in 2021. At its core, Internet Computer Protocol is a blockchain network that aims to bring greater efficiency, speed, and decentralization to smart contracts, computation, and data storage services. The basic idea is to create a new kind of decentralized internet and global computing system where independent data centers globally can join together to create an alternative to the current centralized cloud services providers. Essentially, the Internet Computer Protocol is a way of converting crypto into processing power. The network then decides a fee based on the amount of computing power required to host a developer's project. For as long as the fee is paid, the website will run on the public internet. Fundamentally, the project aims to address flaws associated with the current internet, such as the monopolization of services, poor system security, and the misuse of personal data. But to fully understand what the Internet Computer Protocol does and what makes it different, let's quickly break down the definitions between Web 1, Web 2, and Web 3, and also the definition between the Internet and the web itself. Typically, the words Internet and Web are used interchangeably, but if you want to get technical, the Internet is a series of interconnected computer systems that allows data to travel through, whereas the web refers to the pages or websites you visit while connected to the Internet. To explain another way, the Internet and the Internet Computer Protocol can both be thought of as the highway through which all traffic passes, and web pages are the stops or locations you may visit while driving along the highway, such as petrol stations, convenience stores, etc. However, to be clear, it is not just Web3 pages, as the Internet Computer Protocol is fully compatible with all current Web2 websites and applications. But what exactly is the difference between Web 1, 2, and 3? Web 1 is the original read-only version of the Internet that very few people used or had access to, and even fewer could add, edit, or remove web pages. This was when the Internet was first created and mostly used by universities as a fun side project. This meant web pages that were text-only with none of the features or functions we have come to expect from websites today, including the most basic features like images. Web 2 is the Internet as we know it today and is sometimes called the social web. This was after developments like Java were created, from which an explosion innovation led to the Internet as we know it today with its social media, blogs, apps like Spotify and YouTube, and so on. So, what exactly is Web3? While definitions vary, a common theme of Web3 is the decentralization of the internet. Currently, most websites inevitably end up hosted by a select few cloud service providers, notably Amazon Web Services, Microsoft Azure, and Google Cloud. The problem here comes down to having a single point of failure. Should anything disrupt these very few businesses, the entire internet could come crashing to a halt. As an example, last year, German cloud service provider Hetzner banned all Solana nodes, which resulted in up to 40% of the network temporarily disappearing. To explain why this matters, Solana requires a certain percentage of nodes to confirm consensus. Meaning, had it been a larger or multiple cloud service providers acting together, they could have completely hatted the Solana network until their network's nodes had set up on a rival cloud service provider, if there were any available. Although estimates vary depending on the source, it is claimed as much as 60% of all web traffic goes through either Amazon, Microsoft, or Google Cloud. Highlighting the issue even further, Web3 solution is to have the users host the internet themselves and in exchange give them complete control over how their data is utilized and shared. But how does the Internet Computer Protocol work exactly? Much like the regular internet, the Internet Computer Protocol also runs on a network of nodes. However, unlike your typical network routers, the hosts of the Internet Computer Protocol are the users themselves. Part of what makes the Internet Computer Protocol unique is its consensus mechanism known as Proof of Useful Work. Proof of Useful Work is essentially the ability for a distributed network to execute smart contract computations on multiple nodes and prove that the computations were correctly calculated. These consensus nodes run a highly sophisticated consensus algorithm that leans into the power of advanced cryptography known as chain key cryptography. Chain key cryptography enables nodes of the Internet Computer Protocol to jointly hold cryptographic keys in a way that no misbehaving nodes on the network can perform useful operations with their key, but the majority of honest nodes still can. Now that we know what the Internet Computer Protocol is and how it works, let's explore the tokenomics of the ICP token. The ICP tokens can be used for payments such as for computation required while using the network, staking, and governance. The total amount of ICP is dictated by various inflationary and deflationary effects on the network. However, at launch, there were 469 million ICP tokens created. At launch, the initial token distribution was as follows. 24.72% was sold during the seed round, 23.86% was given to the Dfinity Foundation, team members received 18%, 9.5% went to early contributors, 7% to strategic partners, the pre-sale received 4.96%, 4.26% went to the ICA, which stands for Internet Computer Association, strategic partnerships got 3.79%, 2.4% went to advisors, 0.8% was given away during the community airdrop, while the initial community was given 0.48%, and finally, node providers also received 0.22%. To answer the question in the intro, what is the benefit to end users? First, a quick, cheap network for creating and executing smart contracts, but perhaps more important is the security it can provide for the whole of crypto and not just its own network. The Internet Computer Protocol has noticed a legitimate concern within the architecture of how blockchains are hosted and is actively working towards a solution. I would agree that the truest version of cryptocurrencies should not entirely rely on centralized providers such as Amazon, Microsoft, and Google. This is because for as long as crypto requires centralized cloud services, it is unfortunately not as decentralized or as immune to censorship as we would like to believe. Luckily, the Internet Computer Protocol is looking to fix or at least help reduce the reliance on centralized cloud services, which is good news for crypto overall. Does this mean the Internet Computer Protocol will be the crypto web host of the future? Not for certain, but being the first mover in this space does give them an advantage, and providing there are no major mishaps in management, it still seems likely that the Internet Computer Protocol will continue to do well for as long as Web3 remains relevant. Though, as always, nothing is ever guaranteed in crypto, of course. If you like to know how to create an ICP wallet, check out my article in the description below. And if you like the video on the Internet Computer Protocol, I am sure you will like this one too.